Hi everyone, we are in Unit 5, Week 4, and this week's shared read is called Changing Views of Earth. This is an expository text, and if you remember, expository texts are informational. They're designed to give us more information about a specific topic, utilizing details, scientific evidence to help support the thinking. Expository text will also usually have some sort of visual, so graphs or pictures, diagrams to help you further understand what you are reading. Our essential question for this week is, how can scientific knowledge change over time? We're going to read about how our understanding of Earth has changed along with scientific developments over time. And with that thinking, we're going to take a look at cause and effect. When you read an expository text, sometimes authors will organize information in a way that you can think about something that is causing something else to happen. And so we're going to explore that as we read as well. On the ground, looking around. No matter where on Earth you go, people like to talk about the weather. This weekend's forecast may provide the main criteria for planning outdoor activities. Where does all that information about the weather come from? The ability to predict storms and droughts required centuries of scientific innovation. We had to look up at the skies to learn more about life here on Earth. So if we think of this first introductory paragraph, it really does, make us think about how people began predicting the weather. So it says that people had to look up at the skies to learn about Earth. So this sentence here means that it suggests that studying the Earth from space could help us predict weather more accurately. Long ago, humans based their knowledge on what they experienced with their eyes and ears. If people could heighten their senses, they may not feel so mystified by the events confronting them daily. For example, something as simple as the rising sun perplexed people for centuries. People believed that the Earth stayed in place while the sun moved around it. This was called the geocentric model. In the early 1600s, an Italian named Galileo pointed a new tool called the telescope toward the night sky. As a result of his heightened vision, he could see stars, planets, and other celestial spheres with new clarity. Each observation and calculation led him to support a radical new model of the solar system. In the heliocentric version proposed by the scientist Copernicus, the sun did not orbit the Earth. The Earth orbited the sun. So in this section, on the ground looking around, we gain some insight into a couple of things. One, we learned that long ago people used their eyes and their ears to make decisions. Okay, they had to rely on their senses. We also learned, and because of that, people for a really, really long time thought that the Earth stood still and the sun moved around it. Now, that was called a geocentric model. So I want you to look at this word because it might not be familiar to it. Geocentric, this has some Greek roots in it. Geo means earth. Center, C-E-N-T-R-E, means center, like the center of something. So this thinking was kind of earth-centered, meaning the earth stood still, everything else moved around it. And then we learned that something happened in the 1600s. Galileo created the telescope. And we're given a signal phrase here as a result. So because he developed this telescope, he had heightened vision. And because he had heightened vision, he could see things with new clarity. He could see things more clearly. Okay? And so with each observation and calculation that he made, he came up with this new model of the solar system. So this heliocentric version, which was later proposed by Copernicus, said the sun did not orbit the Earth, So the sun did not move around the earth. Okay, it now said that the sun was the center of everything. Helio means sun, centric, we know it has to do with center. So this new discovery, this new version, is that the earth orbited the sun, which is what we know happens. But none of this could have happened without these scientific inventions, these new discoveries. And if we look at our picture, Galileo's telescope helped prove that Copernicus's heliocentric view was correct. These diagrams show the geocentric, Earth in the center, and heliocentric, sun in the center views of our solar system. We know that this is the correct view of our solar system. So before I move on, I do want to go through and I want to look at cause and effect in this section. So this section is on the ground looking around. And we've already kind of talked about some things. So we know that long ago, people relied on eyes and ears. This is what gave them their information. It was their observations. And because they only could rely on their eyes and ears, they believed that Earth stayed put and the sun moved. And we learned in our Greek roots, this is called a geocentric model. Geo meaning earth. This is from the Greek center, meaning center. Okay, so that's what we learned. Cause, eyes and ears, earth stays put, sun moves. And then something happens. So we learn that Galileo, I need to spell his name right. Galileo invents telescope, and as a result, stars, planets are seen more clearly. And then this actually, I'm going to draw another arrow, okay? Because now stars, I don't know why I'm putting that comma there. Stars, planets seen more clearly. We now know that Earth orbits the sun. And remember, we called this a heliocentric model. And if we use those Greek roots, helio being sun and centric, centered. So sun-centered. So I wanted to give you some insight into cause and effect, because that's what you want to be thinking about as we continue with these next two sections. Is there going to be specific causes and then effects that happen because of those? So we're going to move into our new section, in the sky looking down. New technology allowed scientists to evaluate theories better than ever. Measuring devices such as the thermometer and barometer offered new insights into weather patterns. However, people were still limited to ground-based learning. What if they could travel into the sky where the weather actually happened? So a couple of things in this. We have two words that both have Greek roots, thermometer, barometer. In our English language, when we see a word that has meter on it, that is a Greek root for measure. Okay, so it talks about a measurement, a way of measuring something. So if we're looking at the word thermometer, therm means heat. So if we're putting these together, we're measuring heat, and we can see up here measuring devices. So a thermometer is a device that measures heat. A barometer, I actually had to look this up. A barometer is a device that measures atmospheric pressure. Okay, so we have thermometer, barometer. But my context clues don't help me with this part, so your next best bet would be dictionary. So barometer measures atmospheric pressure, thermometer measures heat. In the mid-1700s, some scientists sent measurement devices higher and higher. At first, they used kites. Before long, hot air balloons offered new ways to transport the tools, and sometimes scientists sent themselves into the sky. However, scientists were not satisfied studying the lower layers of Earth's atmosphere. The more they learned, the higher they wanted to go. They also wanted to obtain information more quickly and accurately. Kites and balloons were hard to control. As a result, they occasionally veered off course or got lost, taking their data with them. Okay, so we have a cause and effect. We know scientists are wanting to be able to study more layers in the Earth's atmosphere. They're only able to study the lower. They're using kites and balloons, and we kind of have our cause and effect. Because kites and balloons were hard to control, they occasionally veered off course or got lost, taking their data with them. So the cause, they're hard to control. As a result, that's our signal phrase. This is the effect. They veer off course, they get lost, they take their data with them. The development of aircraft in the early 1900s promised safer ways to observe Earth's surface and the atmosphere above it. Kites and balloons could reach altitudes of approximately 3 kilometers. By comparison, airplanes lifted scientists to a height of 5 kilometers and more. Radio technology allowed scientists to transmit data from the air to the ground, where other scientists analyzed and compared information. Breakthroughs came fast and furiously. Still, scientists dreamed of reaching even higher. So if we're in this section and we're trying to see some of the technology that's been used, we started with kites and balloons. And then we had aircrafts. Oh, yeah, hot air balloons. Aircrafts. And then we ended with radio technology.